So how can you make a model? To create a machine learning or deep learning model, what you need to do is, first of all, let's define a variable model, and then Keras, we can write Keras. So we are saying that from Keras, go to a section called models, and from that model, from the section model, just grab me this function known as sequential. Right? Fine. Now, in order to add, so this is the model, right? This is where we have defined the model. Okay, don't get confused that this is the model. This is where we have defined the model. Now we have to add neurons in it. How we can do that? We can write model dot add, and after that we can write keras dot layers dot dense. Oh, oops! Before that, I also forgot to tell that you have to do a flattening. You have to add a layer of flattening. Okay. Now what is flattening? I'll just explain in a moment. Yeah. So flatten. So what is flattening? So let's go back. Okay. Let's create a shell here. Yeah. So let's say you have a matrix. You have a matrix random and of 10 rows and 10 columns. Okay. 10 rows and 10 columns. Now, if you multiply this matrix with uh, with any number, let's say a, for example, then what you need to know is a, you can only multiply two matrix or a matrix and a vector only if the column of the first matrix is equal to the row of the second matrix. What I mean by that is np dot, let's create another matrix here, np dot random dot rand. Okay. And if I write 1 here, or if I write 3, and let's write 20 here, this number does not matter for me. Let's let's make an error. So in order to do a matrix multiplication, you can write at the rate and just like that. Okay, and just we'll run it and see. We will get an error. What is the error? The dimensions, the size are different. Size are different. So like I told you, if you need to multiply, if you want to multiply two matrix or a matrix and a vector, you have to make sure that the row of the first matrix is column of the first matrix is equal to the row of the second matrix. Now this will work. Okay, now it worked. Now here is the catch. If you have rows, or let's say if you have columns in a matrix, that column, when it is getting multiplied with another when it is getting multiplied with another matrix, what happens usually is, let's say you have column 1, uh, so in matrix you have column 1 and in A you have certain number, right? So each of the column 1 will be multiplied with the first value of with the values of A1. Alright, now A2 will be multiplied with C1. Similarly, A3 will be multiplied by C1. So C1 will be common here. So all the rows will be will get multiplied with all the columns. Okay. I'll make the next video will be more into linear algebra. So I'll try to cover matrix and what vectors are and what matrix is, and how you can do matrix multiplication and what are the limitations that neural network faced so that it went to a technique called flattening. Okay, so you have xn with c1. Okay. Similarly, you will multiply with x2, sorry, a2 with c1, a2 with c2, a3 with c2, and so forth, unless until you complete you finish multiplying all the rows. Okay, so this is what is happening. Now imagine that you have to find an unknown for each of the column. Okay, so in order to make things simple, if you remember from the slide that I've showed you, each of the neuron will have only one weight, one unique weight. But you know that a matrix will only get multiplied if the size of the row of the first if the size of the column of the first matrix is equal to the size of the row of the second matrix. So in that case, what happened was they tried to flatten the image, or flattening is nothing but resizing the image such that, so I can write resizing the reshaping, so not resizing, reshaping the image such that the first column will have all the multiplication, and so basically converting it into a row or a column matrix or a vector. So here I'm converting into a column matrix, column vector. Okay, now what -1 is saying that you, whatever number you have over here, just make sure you take the multiplication of these numbers and just put here instead of -1. You can just write 10 into 10 as well. Okay, so the only difference is instead of writing 10 into 10, you can write -1 there. In order to not make not make the input data complex, what we do is flatten the image such that all the rows will be converted into one single line. Alright, basically meaning that all the points, like I'll explain this thing to you once again. For example, if you have a matrix like 1, 2, 3 and 4, and then that is the first row, the second row contains like that. What we are doing when we are reshaping is, like, just check the output here. After reshaping, what we are trying to do is we are doing this 1, 2, 3, 4, and then 3, 4, 5 and 6. So we are just reshaping it into this fashion. The information is not lost. Only the only thing is that all the numbers are now arranged one after the other or one below the other. Alright, that's the only thing. Information remains as it is. Only the shape has changed. Alright. So now, if I want to create a neuron, let's say, then I have to use this function called as the dense function. So dense function has something known as units, where each unit corresponds to each of the neuron. So let's say if you want to have only one neuron, then you can write 1. But for now, I will just write 100. So I want 100 neurons. Okay. One more thing that you have to write over here is input shape. Input shape equals to whatever shape you are trying to operate. So we are trying to operate 28 by 28. Okay, cool. So after dense layer, like I told you from the slide before, you have to add an activation function. You have to add an activation function. So I can write Keras layers, and then I'll write, yeah, activation. And what activation we are trying to use? We are trying to use sigmoid. Like I explained, it will convert the number from 0 to 1. There are different activation functions as well, like relu, which converts all the negative number to 0 and positive numbers remains as it is. But in this case, we will convert the number from between 0 to 1. We will transform the number. That's the correct technical word. We will transform the number. And just to make it more clear, we can do this. So here, from here, we are creating deep neural networks, deep neural nets. So if you want, so like I told you, this is the first layer. If you want to create one more layer, all you need to do is do this. Copy paste the same thing. So the first layer will contain 100 units. The second layer can contain 60 units, and it will have the same sigmoid function. Now the last layer will be the output layer, which basically will be equal to the same number of input. Okay, so since we are dealing with 100 digits, which is basically from 0 to 9, so our output will be, we'll write the same thing, dot layers, and we'll write dense, and so the output layer will be actually equal to the input layer, not the input layer, actually the input that you are giving. For example, if you are trying to classify whether the particular animal is a cat or a dog, the number of inputs will be the images of cats and images of dog. So you keep them in a particular folder. Okay, so what are the different categories of images you have? 2. So that will become the output of your dense layer. Similarly, over here, since we are having photos of zeros 1, 2, 3, 4, 5, 6, 7, 8 and 9, our output layer will be 10. So output layer will contain 10 neurons, and again we will add an activation function. So in this case, instead of using sigmoid, we'll be using a probability function which is known as softmax, function. Now this gives us the probability of each of the number being a particular number. For example, let's run this one now. Okay. A second, something is wrong. Keras dot flattened. Um, okay, let's write this extreme dot shape and oops, made a mistake. Made a mistake once again. I made a mistake. Alright, from one I need everything. So model.keras, something is wrong here. Model.add. Okay, I think we have missed. Yeah, we have missed one bracket over there. Yeah. Alright. Layers. It should be layers. Sorry, my bad. Should be layers. Alright, good. So now what we can do is we can actually see summary. But I was also about to explain why we use softmax. Okay, so basically this is a summary of all the layers that you have put. So why do we use softmax? Basically, let's say you have an image of a cat or a dog. So softmax function, what it does is it tells you what is the probability that this input is a cat or a dog. So it gives you a probability rather than saying it is a cat or a dog. So let's say 75% it says that a particular input belongs to cat, belongs to dog, and 70 or let's say 32% says that it belongs to cat. So this is what a softmax function does. If you have more output, making sure that you have the same number of input, like you have a snake as well, so it will tell you, or it will output a percentage, a probability saying that you know that snake is 84% or something like that. So softmax function gives us a probability of what each of the input corresponds to, or probability of each of the input saying that this input belongs to a particular output. If that makes sense to you, right? So each of the output basically gets a particular probability. Yeah, each of the output basically gets a particular probability saying that this particular input belongs to this category. All right, and the probability with the highest and the output with the highest probability gets selected as the final output. Okay, so that is the function of a softmax activation function. Okay. Now coming to the next part is after you have designed your model, the next thing that you do is you compile the model. Compile the model. And the first thing that you do is optimize. So we'll talk about optimizer in the coming videos, but what optimizer does is that it changes the weights such that it gives you the correct answer. So basically training means not changing the input but changing the weights and the bias. Remember that the base and the bias gets multiplied with the input. So if you have a correct weight and a correct bias, it will actually it will give you the correct answer. So optimizer means optimizing or doing a repetitive process of making sure that the machine learns. Okay, so the more correct the weight is, the more closer it gets to the answer. The more closer the input signal gets to the answer. Okay, so here we'll be using SGD, sorry, not 6, SGD, which basically means stochastic gradient descent. Again, I'll do a video on this. And then learning rate. Let's say this learning rate is a number which actually nudges the weights in a particular fashion and optimizes it. Because if you have learning rate, proper learning rate, then the machine learning will be faster, or it can be, if you don't have correct learning rate, the machine learning will be slower and incorrect as well. So faster does not mean correct, but faster actually can be correct and cannot be correct as well. It can be both depending upon the problem that you have. Okay, for now on, just remember that optimizer basically corrects the weights and the bias. Okay, cool. So then we have loss. So what is a loss? Loss function is basically saying that whether what is the error that the model is making. For example, if a student scores 8 out of 10, it means the error made by student is 2, right? Similarly, the model checks itself with the original answer. Remember the original answer we give y. So the model checks itself with the original answer, and if the predicted answer is far from the original answer, it tries to correct itself using the optimizers. Okay, so I'll repeat that once again. If the predicted answer made by the machine is very wrong, okay, then it will correct itself using the optimizer. Okay, this is used to check how wrong the answer is. Okay, and this is used to make sure that the losses are less. Okay, so we'll be using sparse, I think, just make sure that my spelling is correct. Sparse categorical entropy. Sparse categorical entropy, and we'll also add a matrix to see the graphs, to store the values. Alright, so I want accuracy. Okay, now moving on. So once this is done, then what you can do is you can train the model, or you can teach the model. In order to teach the model, what you will do is you will write model.fit, and you will pass your x train and y train. Okay, you pass your question and you pass your answer, and then you say for how much time you want to teach them. So epochs is the, you can say it as a for loop, is a repetition. Let's say I want to teach it for 30 times. And then you have validation split. I'll use validation split because I haven't created validation data. So what is happening, what you can understand validation split as, let's say for example, after conducting a class, you give students some questions to answer on the same day. For example, let's say you have taught students 10 questions with answers on that particular day. So what you will do is you will take 3 questions from the questions that you have taught. Okay, not new questions, but same questions. Any 3 questions from the 10 questions that you have taught, and you ask the students to answer them. All right. If the students answer all the 3 questions correctly, it means they have learned perfectly. Otherwise, there is some sort of error that needs to be rectified. All right. So this validation split will actually say that after training a particular number of photos, just make sure that just cross validate and check yourself how correct you are, right? So I'll use 30% of the data here as well. So epoch validation split, everything is done. All right, so now we'll train the model, and before that you will get a lot of warnings. So in order to you know in order to escape the warning, this step you should do actually in the beginning. You write import warnings, and warnings dot filter warnings. You will write ignore. Just ignore the warning that I'm getting. Okay, this basically means that, let's see if there's an error. Okay, x train is not defined. I think, yeah. Alright, since we have trained till 30 epochs, you can see that there are some sort of values that you get. One is the loss, one is accuracy, validation loss, and validation accuracy. To make sense of what are all these, I'll just plot a graph for you to understand. Let's say plt.figure. Okay, let's start with plt.plot. And what I'll do is I write history. Remember, I've written history on top here. Just close this. I've written history on top here. The same thing I'll write here, history. And in after history, I'll write history once again. And then I will write accuracy. Yes, just like that. And I will write label to make sure that I label all the lines that are being displayed. Accuracy. I just copy this 3 times. 2, 3. Connected 5 times. Right. So then let's say you write here validation accuracy, and you add just validation. Then you have loss, and then you have validation loss. So I write val loss, and same thing, just copy paste. Alright. Now before plotting it, let's plot and then see what other things we can add. You see the graph is very small, so yeah, we can actually, and there is no labels, right? There is no labels. So first of all, let's increase the size of the graph. So we can write figure plt.figure, and we can write fixed size, and we can write I want x-axis to be 15 units long and my y-axis to be 8 units tall. Okay. Similarly, I'll write plt.legend because I need those legends, the legends that you see here, the labels that you see here to be printed. So I'll write legend. I'll just write it just like, I'll just leave it as it is, and plt.show. Right. Let's see. Cool. This is how the graph looks like. Okay. And to explain this graph to you much more clearly, you need to understand two things. One is that the accuracy should increase to 1. Okay, it should increase to 100%, and the error or the loss should decrease towards 0. That's the two things you need to understand. Since this model is actually quite good enough, I will not explain what overfitting and underfitting is, but just to make sure, you should know that overfitting and underfitting is not good for a model. Okay, so in the next video, in the coming videos, I'll explain what overfitting and underfitting is and how you can control overfitting and underfitting. But before that, I'll just try to complete linear algebra and the thing and the techniques or the algorithms that helped us to create this model. Okay, so stay tuned for that as well. And before closing, I'll just like you to see one more thing. I need to evaluate the model. So what I can do is I can write. So I'm actually testing the model, how good the model is. If the model is not good, remember you have to train the model one more time. Okay. So the model is performing 68%. As far as I can say that the accuracy of the model is 68%. Now guys, if you want to increase accuracy, make sure you do the training or you change the epoch, this epoch to maybe 1000 or 500 or 1000. Okay, then you will tend to see a lot of different changes in the model itself. And one more thing I would like you to try is don't do the scaling, just do the scaling with do the same thing without scaling the input variables. Okay, just do it without scaling, then you will see the difference. Alright guys, so this was it for the video, for the first tutorial, how you can create your own neural network without any complication, just using a library known as Keras. Alright, I hope you have enjoyed it, and let me know in the comments below if you have any doubts, so that I can rectify it, and just help me to build this community. This is my first video, just like you to help me to build this community and to explore and to actually give more information about maths. Alright, okay then, see you, have a great day, have a great night.